Look around you, the water you drink, the air you breathe, the milk in your fridge. Are they pure or are they mixtures? And if they're mixed, how can we separate them? Welcome to the world of pure substances and mixtures. In this lesson, you'll discover what makes something pure, how mixtures form, and the clever techniques scientists use to pull them apart. Let's dive in. Matter is either pure or mixed. Pure substances have a fixed composition and fixed properties. Think of pure gold or pure water. Mixtures, on the other hand, are made of two or more substances combined together. Their composition and properties can vary depending on the ratio. Mixtures come in two types. Homogeneous mixtures have uniform composition throughout. When you look at them, they appear as one phase. Heterogeneous mixtures have non-uniform composition. You can see different parts or phases clearly. Common homogeneous examples are salt water, sugar solution, and air. Heterogeneous examples include oil water, sand water, and fruit juice with pulp. A solution is a homogeneous mixture made of a solute and a solvent. The solute is the substance being dissolved, and the solvent is the substance doing the dissolving. Most solutions you'll encounter have water as the solvent, but solids can dissolve in solids too, like metals in alloys, or gases in liquids, like carbon dioxide in soda. Solutions have distinct properties. First, they are transparent because the solute particles are extremely small, smaller than 1 nanometer, that is 1 billionth of a meter. Because particles are so tiny, they do not scatter light. Light passes right through. This is why salt water looks clear like water. Solutions also do not settle over time, and they pass through filter paper because there is nothing to catch. Solutions can be dilute or concentrated. To measure concentration exactly, we use mass by mass percentage, which equals mass of solute divided by mass of solution times 100. For example, if we dissolve 10 grams of salt in water to make a total solution of 100 grams, the mass by mass percentage is 10 divided by 100 times 100, which equals 10%. Mass by volume percentage uses volume of solute in milliliters and volume of solution in milliliters. A suspension is a heterogeneous mixture made of tiny particles suspended in a liquid. Unlike solutions, particles in suspensions are much larger, bigger than 100 nanometers. Because particles are visible to the naked eye, suspensions look cloudy or turbid. Over time, these particles settle to the bottom because they are heavier than the liquid. Suspensions can also be separated by filtration. The filter paper traps the large particles while the liquid passes through. Suspensions scatter light, so a beam of light passing through becomes visible. You can see the path of the beam. This is the beginning of the Tyndall effect, which we will explore more deeply soon. Colloids are a middle ground. Colloidal particles are between 1 and 100 nanometers, larger than solution particles but smaller than suspension particles. Because colloidal particles are so small, colloids appear homogeneous to the naked eye, but they are actually heterogeneous. The particles are separate from the liquid, not truly dissolved. Importantly, colloidal particles do not settle because they are so light and constantly bombarded by fluid molecules in random motion. This is called Brownian motion. Colloids cannot be separated by filter paper because particles are small enough to pass through. However, centrifugation, spinning rapidly, can separate them. The Tyndall effect is the scattering of light by colloidal particles. When light hits these tiny particles, it bounces in all directions instead of going straight through. This is why the sky appears blue. The atmosphere contains tiny colloidal particles and gas molecules. Blue light has a shorter wavelength, so it scatters more easily than red light. This scattered blue light reaches your eyes, making the sky appear blue. When the sun is low near the horizon, the light travels through more atmosphere, so red and orange light scatter too. This is why sunsets are red and orange. Car headlights are visible in fog for the same reason. Fog contains water droplets that are colloidal in size. The light from the headlights scatters off these droplets, making the headlights stand out in the mist. Milk looks opaque and white because milk is a colloid of fat globules in water. Light scatters so much that you cannot see through milk. This is the Tyndall effect in everyday life. Evaporation is a separation technique used when a solid is dissolved in a liquid. We heat the mixture to boil away the solvent, leaving the solid behind. A classic example is extracting salt from seawater. Seawater contains dissolved salt which we cannot see or filter, but when heated water evaporates as steam and salt crystals are left behind. Evaporation works for any dissolved solid: sugar from sugar water, copper sulfate from its aqueous solution, and many other examples. Filtration is used to separate an insoluble solid from a liquid. Insoluble means the solid does not dissolve, it just floats or settles in the liquid. In filtration, we pour the mixture through filter paper, which is porous. The paper has tiny pores that allow liquid molecules to pass through but trap larger particles. The liquid that drips through is called the filtrate. It should be clear or nearly clear of particles. The solid left on the paper is called the residue. Filtration does not work for solutions because the solute particles are too small. They pass right through the filter paper with the liquid. This is why we use evaporation for solutions instead. Centrifugation is a separation technique where we spin a mixture rapidly. The spinning creates a centrifugal force that pushes denser particles outward and downward, making them settle much faster than they normally would. A common example is separating blood into components. Blood contains red cells, white cells, and plasma. When blood is centrifuged, the denser red cells sink to the bottom fastest, white cells settle above them, and the lightest plasma floats on top. Another example is separating cream from milk. Milk is a colloid, and centrifugation forces the fat globules to the bottom while watery liquid rises to the top. Centrifugation is very effective and fast compared to letting things settle naturally, which can take hours or days. Distillation is a separation technique for miscible liquids, liquids that mix completely with each other, like alcohol and water. In simple distillation, we use when the two liquids have very different boiling points. For example, alcohol boils at 78 degrees Celsius and water boils at 100 degrees Celsius. In a simple distillation setup, we heat the mixture. The component with the lower boiling point evaporates first. The vapor rises through a condenser tube where it cools and condenses back into a liquid which is collected in a separate flask. For liquids with similar boiling points, we use fractional distillation with a fractionating column. This column has a temperature gradient allowing a more precise separation. Fractional distillation is used for crude oil separation into petrol, diesel, kerosene, and other products, and for liquid air separation into nitrogen and oxygen. Chromatography separates components of a mixture based on how differently they adhere to a surface. The most common type is paper chromatography. In paper chromatography, we place the paper strip in a solvent liquid. The solvent soaks up through the paper by capillary action. As it moves upward past the ink dot, each dye component travels at a different speed depending on how strongly it adsorbs to the paper. A dye that adheres strongly to the paper travels slowly and stays near the bottom. A dye that adheres weakly travels quickly with the solvent reaching the top. Chromatography is used to separate ink dyes from markers and pens, to identify additives in food colors, and to analyze blood pigments in forensics. Sublimation is a separation technique for volatile solids, solids that turn directly to vapor without melting when heated. Examples include camphor, used in mothballs, and ammonium chloride. In a mixture with non-volatile solids, heating causes the volatile solid to sublime, while other solids remain behind. Magnetic separation is used when one component of a mixture is magnetic. We use a magnet to pull out the magnetic component. Magnetic separation is simple, fast, and used in many industrial processes to purify materials and recover valuable metals. An element is the simplest form of matter. Elements cannot be broken down into simpler substances. There are 118 known elements, each made of atoms of one type. Elements are organized into three main categories: metals, nonmetals, and metalloids. Metals are shiny, conduct electricity, and are usually solid at room temperature. Examples include gold, iron, copper, and aluminum. Non-metals are not shiny, do not conduct electricity well, and can be solid, liquid, or gas at room temperature. Examples include oxygen, nitrogen, carbon, and sulfur. Metalloids have properties between metals and nonmetals. They are semimetals and conduct electricity poorly. Examples include silicon, arsenic, and boron. A compound is formed when two or more elements chemically combine in a fixed ratio. Unlike mixtures, the elements in a compound are bonded at the atomic level. The properties of a compound are completely different from the properties of the elements that make it. Hydrogen is a flammable gas. Oxygen supports combustion, but water is a liquid that extinguishes fire. Sodium is a soft metal that reacts violently with water. Chlorine is a toxic green gas, but when combined, sodium and chlorine form sodium chloride, table salt, a white solid safe to eat. Compounds can only be separated into their component elements by chemical methods, not physical methods. Heating, filtering, or evaporating water will never separate it back into hydrogen and oxygen gas. Let us summarize the three key categories of matter and how they differ. Elements have a composition of just one type of atom. They cannot be broken down by physical or chemical means. They are the simplest form of matter. Compounds are made of two or more elements chemically combined in a fixed ratio. Their properties differ from their component elements. They can only be separated by chemical methods. Mixtures are two or more substances physically combined. Their composition and properties are variable depending on the ratio. They can be separated by physical methods like filtration, evaporation, or distillation. This is the core framework for understanding all matter. Pure substances are either elements or compounds. Mixtures are combinations of pure substances. You've just learned the foundation of matter. Pure substances are fixed and simple. Mixtures are variable and complex, but both are essential to chemistry. Remember, solutions are transparent and don't settle. Suspensions are cloudy and do settle. Colloids scatter light and don't settle but can be centrifuged. And you learned 7 separation techniques. Each works for different types of mixtures. Choose the right one and you can separate almost anything. Finally, remember the hierarchy. Elements are the simplest, compounds are made from elements, and mixtures are combinations of either elements or compounds. Now it's your turn. Try solving some practice problems. Can you identify if a substance is pure or a mixture? Can you choose the right separation technique? If this video helped you, please like and subscribe for more chemistry lessons. Leave a comment if you have questions. See you in the next video.